Okay, so I hope all of you learned the Lagrangian and Hamiltonian mechanics. At least the first years maybe you would have started now, right? But second years I think you completed. So the Lagrangian mechanics is the next version of Newtonian mechanics. Something like we have a mobile, right? Olden days we have the very touch screen mobile. Then slowly technology improved. So next version, it will improvised mobile came. Now I think we all have there is no, in fact in our period we have a phone, there will be half of the portion will be typing keyboard, right? But nowadays everything is touch, right? So as technology improves, the sophistication of the devices are getting improved. Similarly, the Lagrangian is kind of sophisticated version of Newtonian mechanics. So it's an improvised version of there are certain issues, maybe certain difficulties are in Newtonian mechanics, especially like vector approach. Because in Newtonian mechanics, the fundamental equation is a vector equation, right? F is equal to ma or F is equal to v by dt. So those things are a little difficult to deal with in combinatorial problems. So in Lagrangian mechanics, we move from this vector approach to scalar approach. And what is the important equation in Lagrangian mechanics? One is the definition of Lagrangian. What is that? L is equal to T minus B. The other one is Euler-Lagrange's equation. There are two important results, right? One is Lagrangian. L is equal to T minus B. Let us see. What is our ideal equation? d by dt of rho L by I is equal to 1 to up to n. N is the number of, what is GC? Generalized coordinates. So we have n number of generalized coordinates, we have n number of Euler-Lagrange equation. Okay, but the very crucial point is this L is equal to, well, T is the kinetic energy and B is the potential energy. And another important point, this L must be a function of Q dot Qi and possible type. It is not a function of our normal Cartesian coordinates. It is a function of generalized coordinates. Okay. So, of course, it's a detailed theory. I am not going to do it. But how to construct Lagrangian? That's very, very important. So, if you know the construction, I think you can go for any system. Maybe I will give you some kind of simple steps. How to construct Lagrangian. The first step is identify the number of constraints, I mean constraint equation in the given system. So as soon as if they give some system, you look at the system, what are the constraints? And I mean constraint means, suppose if I throw the object, right, it is moving. Right? So while it is moving, it experiences certain constraints. Sometimes it may not have any constraint. For example, you take a butterfly. Butterfly can move anyway, any arbitrary, right? It has no constraint. Suppose, for example, I am moving here and there, right? So mostly humans are constrained to move only in the plane. I cannot arbitrarily move upward, right? Suddenly I cannot move, right? Because there is a downward force. Unless somebody is lifting me, I can move. But in general, I am moving in a plane. Like take a, for example, a student sitting in the classroom. So if a teacher is inside the classroom, the student simply has to sit, right? He cannot simply go out because teacher is here. So he has to sit. So that's a constraint, right? So similarly, we have so many constraints on the system for the motion of the system. So constraint basically what will happen? It will restrict the physical motion. You understand? Constraint basically is a restriction of physical motion. So that is what I mean a constraint. So whenever the system is given, you try to identify what are the constraint equation. So let us say that the constraints equation k in number. Okay, then the number of generalized coordinate n is equal to v. So whenever you identify, okay, I have some 10 constraint equation. Okay, then what is here n? N is the number of particles. So to find out the number of generalized coordinates, the first important, you should know what are the constraints involved in the system, and you try to express in terms of equation. So like constraints you cannot write as equation. Will come under non-holonomic constraints. So here what I mean is that holonomic. I think you all heard about holonomic, non-holonomic, rheonomic, scleronomic, all these things. So okay, I don't want to go to that theory, but if you are able to express equation as constraint as an equation, the number is some number k. K can be 1, 0, 2, 3, 4, 5, right? Then the number of generalized coordinates will be 3n minus k. Okay. Right. Next step is, once you identify the number of constraints, the number of generalized coordinates, the next step is choose suitable choice of generalized coordinates and express it in terms of Cartesian coordinates. Once you identify number of generalized coordinates, next step by looking at the problem, we have a Cartesian, we have a spherical, we have cylindrical, various types, right? Which one is most suitable for the given problem? Choose one. This is come only after some kind of scale. Which one I have to choose? Only after it will come only after I have some enough experience. At least you can problem solve the experience. Okay, this is better. Right? So that I will show you. For example, you take a simple pendulum. Simple pendulum is oscillating back and forth. So basically, it is an angular oscillation. So in the case, instead of choosing Cartesian coordinate system, better to choose plane polar coordinates. Angular oscillation. So that will be easier. Suppose if object is moving in the straight line, the plane is devoid, then xy is more comfortable than plane polar. Suppose if anything goes in the sphere, then instead of choosing xy, choose spherical polar. Suppose anything goes in the cylindrical, our system possesses some cylindrical symmetry, then it is better to choose cylindrical polar. So the generalized coordinate nature depends on by the given problem, given system. Okay. So once you choose the generalized coordinate, then you try to express the generalized coordinates in terms of Cartesian coordinates. So what I mean here are the other way. Choose suitable choice of generalized coordinates and express Cartesian in terms of, I will write it the other way. Is express Cartesian coordinates in terms of generalized coordinates. Then third step, so what I mean here, this Ri is equal to Ri Q1, Q2, Q3 up to Qn. Here R represent normal coordinates, Q1, Q2 represent generalized coordinates. Cartesian coordinates are generalized coordinate. Remember, even one Cartesian coordinate can be function of all the generalized coordinates. Right? So, fine. Next step, now third step. Express the kinetic energy in terms of generalized coordinates and generalized velocities. I mean here kinetic energy is nothing but T. So what I mean here, T must be function of Q1 dot, Q2 dot up to Qn dot, possibly Q1, Q2. So for third step, the first step identify the constraint. Second step, write the generalized coordinate and convert, get the transformation equation. Cartesian in terms of generalized coordinate. Third step, another construct the or we express the kinetic energy. Then fourth step, express or write the potential energy E again in terms of generalized coordinates and generalized velocity. In general, right? So most of the case it will depends on generalized coordinate. Very few cases like charge body moving electromagnetic field. So they are generalized velocity. So now write. Now substitute P and V in L is equal to P minus V. But now T is also function of generalized coordinate, generalized velocity, and V is also function of generalized velocity, generalized coordinate. So now automatically L is also function of Q dot Q or cosmic time T. Right? So now I construct the Lagrangian. Last one is apply L into Euler Lagrangian equation to get equation of motion. Once you apply this L into EL equation, Lagrangian equation, you will get the equation of motion. Then that is straightforward to solve it. So these are the maybe 5 to 6 steps. So in the follow up straightforward, we will get the result. So let me just I will show you maybe demonstrate one example. I can take a simple pendulum. So simple pendulum. This is L, this is M. Okay. Now it is moving back and forth. This is the system. What is first step? Identify number of constraints. How many constraints there are? So for moving this object, the object over this mass cannot move anywhere, right? So it can only move along this arc, right? Which means there is some constraint to move only along the arc. Not it cannot move this way or this way or this way. There is some kind of constraint to move only this arc, not anywhere else. There is a constraint. Physical. What is the constraint? It is a restriction to for the physical motion. So this is the constraint. What is the equation of constraint there? So wherever it can be here or it can be here, what is constant? L has to be constant. So why it cannot move here? Why it cannot move this position? Because L will change. So it is moved in such a way that to keep the L is constant. So L is constant is a constraint. Yes or no? Yes. Right? If you think of it, if you place x, y, then I can say that this is the x coordinate plus y square is always constant. They both are same. Either L is equal to constant. If you take x and y coordinate of this particle, always it has to satisfy this equation. It's a circle equation. Right? Any other constraint? So in the plane, it cannot move anyway, so it can only move along arc. Can move out of the plane, it cannot move out of the plane. Which means, so while it is moving, its x and y are changing, but it cannot come out of the plane. Which means what? The z coordinate has to be always 0. Right? Yes, it cannot come out of the plane, right? If you think of this is x, y plane, then it cannot come out of the plane. So z is equal to 0. So now I have two constraint equations. One is x square plus y square is equal to L square. Z is equal to 0. Any other constraint? I think almost I got all the information constraints. So I have now how many? What is the k value here in this case? Here k is equal to 2 because I found two constraints. So k is equal to 2. Then what is the number of generalized coordinate? 3 into 1 minus 2. So first step is the first step for number of analyzed coordinate n is equal to 1. First step is over. Is this clear? So I found two constraint equation. Then number of analyzed coordinate is 1. So what essentially implies in general. So what is the meaning of generalized coordinates? In general, any object has a 3 degree of freedom. It can move x direction, can move y direction, can move z direction. But if the constraints are introduced in the system, it will try to reduce the degree of freedom. Understand? In general, particle has a 3D. Why is 3? Because it's the 3-dimensional space. So in general, any object has a 3 degree of freedom. Whenever constraints are present in the system, it will try to reduce the degree of freedom. So how many constraints present? That much number of degree of freedom is reduced. So here I have two constraints. So in general this object has a 3, but since I have two constraints, so 3 minus 2, essentially constraint to limit the degree of freedom. So there is another concept called degree of freedom. So the number of generalized coordinate is equal to degree of freedom. Right? So what is the meaning of generalized coordinate? It is a minimal number of coordinates which will explain the motion of the object completely. If I know only one coordinate, I can be able to explain all the motion of this simple pendulum. So what is a generalized coordinate? It is a minimal number of coordinates required to explain the motion of object completely. So now because of the constraints, if I know one coordinate, I am able to get the other two coordinates. In fact, other coordinates are fixed, always 0. So if I know x, y is always fixed because what is the y? If I give you the x value, what is y? It's nothing but L square minus x square. So if I know x, I know what is the y. Or if I know y, I know what is the x. So அப்போ ஒரு வேல்யூ கொடுத்தா போதும்னா அது மத்த ரெண்டு வேல்யூ. That's the meaning of going from coordinates to generalized coordinates. Okay. Now what is the second step? Choose suitable choice of generalized coordinates and express Cartesian coordinates in terms of. So இங்க வந்து என்ன பண்ணலாம்? எனக்கு வந்து ரெண்டு ஆப்ஷன் இருக்கு. Since z is equal to fixed ஆயிடுச்சு அப்ப ஒரே ஆப்ஷன் அது either I can choose Cartesian xy choose பண்ணலாம் அல்லது வேற என்ன choose பண்ணலாம். இது planar motion தான். அப்போ இது better to choose either Cartesian or plane polar. பட் எது வந்து அட்வான்டேஜ் ஆகும்? இப்போ நீ ஒருவேளை suppose if you choose x and y or sorry if you choose x right now y choose பண்ணி either you choose yes x or y. பட் என்ன பிரச்சனைனா see Roper what is how it related look like very like a complicated equation right. For example y square is equal to l square minus x square that's square root. What is y from this? Y is equal to square root of look like square root and square. And in the course of motion both x and y are changing. If you look at move ஆனால x மாறுது y மாறுது. அப்ப இத விட என்ன பண்ணலாம்னா if I choose in the plane polar coordinate there are two coordinates right? One is r and theta. In the entire course of motion if you choose a plane polar coordinate எது மட்டும் மாறுது? theta மட்டும் தான் மாறுது. r மாறுது. ஒன்னு கான்ஸ்டன்ட் ஆயிடுச்சு இன்னொன்னு வந்து மட்டும் மாறுது. இங்க பாருங்க suppose if you choose Cartesian ரெண்டுமே மாறுது x மாறுது. So instead of choosing x or y it is better to choose plane polar coordinate where one is constant one is only variable. So that's why I question சொல்லிருக்கேன் choose suitable choice of coordinate. Therefore order by scale. So second point is so choose plane polar coordinates. Or theta. In this case, of course, L. The length is the radial coordinates are L and theta. Okay. So now I chose generalized coordinate. So in the L theta, எது வந்து நம்ம choose பண்ணலாம்? ஒண்ணா choose பண்ணலாம். That is equal to 1. Choose plane polar coordinates and the generalized coordinate is. ஏன் theta choose பண்ணிருக்கேன்? L is constant. So generalized coordinate is the base of generalized coordinate. Instead of choosing x or y, I choose theta. ஏன் theta choose பண்றேன்? The entire course of motion theta is changing. So if I know theta value, which means I can know what is the other equation, other values. So what is the second step now? Choose the suitable choice of generalized coordinate and express Cartesian in terms of generalized coordinates. Okay, now let us express. What is the x? So if I choose this is the x axis y axis corresponding what is x component? This is the x component. This is the y component. Am I correct? This projection is x component. This projection is y component. So what is the x value now? Cartesian x is equal to this is the theta. What now? L sin theta. Is this clear? Then y is it downward, right? Negative, right? Negative axis. So it's a minus L cos theta. So what I mean? I express Cartesian coordinates in terms of. So another x is a function of generalized coordinate. What is generalized coordinate here? Theta. Y is a function of generalized coordinates. இது முடிஞ்சா next step என்ன பண்ணனும்? Right? The kinetic energy. But kinetic energy what is kinetic energy? L is equal to 1 by 2 of x naught square and z naught z is equal to 0 and it is not going in out of the plane. This is kinetic energy. About what is x naught from this? What is x naught? L cos theta into y dot now
L sin theta.
L sin theta. Yes or no? So now substitute. Now do it. X dot square now. L square cos square theta. Theta dot square. L square. Okay. So now I completed the step 3. Now look at T is only function of generalized coordinate. Of course, in the cos square because sin square are 1. So what is that? So now I write T is equal to 1 by 2 m L square. All of them. So it's only function of generalized velocity. Mostly with that. ரொம்ப rare generalized function of the coordinate. So for third step முடிஞ்சிச்சா? Fourth step என்னது? So in this case potential energy, right? V is equal to, it is moving along the gravitational force. So V is equal to mgy. But what is y? Minus L cos. Yes. So V, and also look at V is only function of generalized coordinate, right? Then last step, L is equal to 1 by 2 ml square theta dot square and plus mgl yes. So now I have Lagrangian. Now next step is find out to apply the Lagrangian equation. And what is that? D by dt of dou L by what is Q here? Theta dot minus dou L by dou theta is equal to 0. Now we should find out what is dou L by dou theta dot. What is dou L by dou theta dot? ml square. What is dou L by dou theta? Minus mgl sin theta. Substitute that. So no work. Now d by dt of dou L by dou, so which means I have to differentiate this with respect to time. Now about ml square and now minus plus ஆயிருமா mgl or I can remove the L and finally we have a theta dot is equal to g by L. இதான் வந்து already நம்ம the equation, the differential equation for pendulum, not simple pendulum. ஏன் pendulum சொல்றேன்? Physical pendulum சொல்றேன். Sin that. Substitute the, we use a small angle approximation is a simple. So this is the equation of motion, or differential equation of the this pendulum. This is called constructing Lagrangian and come up to the EL equation. Of course, next one is typical straightforward to find the solution of this. Solution is just the theta is equal to a sin omega t plus phi. Is this clear to everyone? These are the steps. Of course, Lagrangian is really a vast and very interesting theory, but to solve, to do some kind of problems and to this kind of solutions, you can follow this kind of general rule. So every one generalized coordinates ஒரு step up பண்ணீங்கன்னா easily construct the equation. Any clarification, any doubt? Okay, now let us move on to the question number 1. A particle of mass m slides under the gravity without friction along the parabolic path y is equal to ax square, axis shown in the figure. Here a is constant, the Lagrangian of the particle. So I have a kind of இந்த மாதிரி ஒரு ஷேப்ல ஒரு வயர் இருக்கு, அந்த வயர்ல ஒரு பார்ட்டிகல் வந்து remove ஆகும். So understand the question. So I have some kind of rod, maybe run some kind of rod or string something in this shape. Y is equal x square form la ஒரு ring மாதிரி இருக்குன்னு வச்சுக்கலாம். அதுல வந்து ஒரு பார்ட்டிகல் மூவ் ஆகும். Right? So what is the Lagrangian? So now what is the constraint equation here? Question number 1. என்ன constraint இருக்கு இதுக்கு? So this one is 1. So particle can only move along this wire, can't move anywhere. So இது ஒரு constraint தானே. But what is the constraint equation? Y is equal to ax square with x square. இது ஒரு constraint. Any other constraint? Z is because it cannot move out of the plane. So Z is very good. So we have a two constraint equation. So first step என்னது? K is equal to 2. அப்ப என்னது? Okay, second step என்னது?
Choose the coordinate.
Suitable coordinate. இதுக்கு என்ன ஆகும்? இதுல வந்து ஒரு symmetry எதுவுமே இல்ல, right? It's not moving in a circle or something. So it's better to choose Cartesian. So suitable GC is Bx. Because x, if I know x automatically y is fixed. Right? Next step, what is the and express the Cartesian coordinates in terms of already the generalized coordinate Cartesian coordinate don't need the second step. Because if I know x automatically y is fixed. This is simple analysis. Third step another kinetic energy. What is kinetic energy? 1/2 1 m. Of course, z dot barabar hai na, because there is no z direction motion. So x dot, okay. What about y dot?
2x.
2x. X dot, very important. Mother brother. 2ax into x dot. So now substitute. So t is equal to 1/2 x dot square plus 4a square x square. Am I correct? Y square dot square. Apna we will take 1/2 m x dot square 1 plus 4a square x square. Oh. So this is the kinetic. Now look at the kinetic energy is only function of Cartesian. What we call the generalized coordinate. Please understand, I am repeatedly telling kinetic energy potential is only function of Cartesian generalized coordinates and generalized velocities. And fortunately here the generalized coordinate is the Cartesian coordinate. But previous example pathina t is a function of theta dot, p is a function of theta. அதே மாதிரி எல்லாத்துலயும் சில கேसेसல generalized coordinates வந்து Cartesian ஆச்சுனா பாக்கும்போது எல்லாமே Cartesian ஆகும். Okay, so you should not think that always Cartesian. Okay, fine. Now next step என்னது பாருங்க. Potential energy, what is potential energy? mg y. mg. Again look at the potential is only function of generalized coordinates. And generalized coordinates here is x. Fine. Now next step. L is equal to p minus v. So 1/2 m x dot square 1 plus 4a square x square minus mga x square. So this is the Lagrangian for this system. In the option இருக்கு பாருங்க. Which option we are getting? B or B. Question number 2 பாருங்க. அதோட எக்ஸ்டென்ஷன் ஆப்ஷன் நம்பர் 2. அங்க இருங்க. What is the equation of motion for this above Lagrangian? What I want to be out to apply to the Euler Lagrangian. What is Euler Lagrangian equation for this system? d by dt of Dou L by
X dot
dou x dot minus dou L by dou x. There should be no y. Yeah. The generalized Lagrangian equation only in terms of generalized coordinates. எத்தனை காரணம் வரும் இங்க வந்து x வந்து ஒரு generalized coordinate previous case only theta one generalized coordinate so all theta தான் வரும். Okay, so now find out what is dou L by dou x dot. What is dou L by dou x dot? Mx dot 1 plus, am I correct? அது ஒரு மல்டிப்ளிகேட்டிவ்ல இருக்கு பாருங்க. It is not in the addition, it is multiplicative. அப்ப அப்படிதான் இருக்கும். Mx dot. Okay, then what about dou L by dou x? சொல்லுங்க.
M whole அடுத்து x dot square 4a square x minus
sorry, mx dot square 4a square x வருதா? Okay, very good.
minus g into 2ax
2a
x.
correct ah? Am I correct? Good. Okay, now what is d by dt of dou L by dou x dot?
One plus 4 a square.
என்னப்பா?
1 plus 4 a square x.
1 plus 4 a square x square
Whole term into m x double dot.
okay.
Option C, sir.
Option
C.
இதுல இருக்குல்ல அதான் சேர்க்கணும்ல சரி ஓகே இன்னொரு காய் see what is equation இத வந்து டைம் கொடுத்து டிஃபரன்ஷியேட் பண்ணனும் you differentiate this what about this one this x also depends on time right so appo this u method you want to differentiate so appo you keep let us first do it like this keep this is a constant mx dot if it is differentiable now we have a 8 a square x into x dot plus 1 plus 4 a square x square into
mx double dot.
So இதுதான் போனேன் so this is the first term so now you write it m x double dot x mx mx dot square into 8 m a square x into x dot square I just multiply 8 m a square x dot square x plus m x double dot plus 4 m a square x square etc. This is the first term minus 4 m a square x dot x into x dot square minus 2m a gs is equal to இத கேன்சல் பண்ண முடியுமா பாருங்க
4m terms.
so இது மட்டும் போடலாம் I think this I can do it right am I correct so m x double dot plus 4m a square x square x double dot plus 4m a square x minus 2mg ax is equal to 0. So which option we can now take off something they are taking right? எது இருக்கு பாருங்க so mx dot மட்டும் காமன் எடுத்துக்கிறாங்க டபுள் டாட் என்னது m into x double dot 1 plus 4 a square x square is equal to 2 mg ax minus 4 m a square x dot square. And the m remove பண்ணிருங்க. Finally I think option இது வரும் நினைக்கிறேன். ஆப்ஷன் பி வரும். செக் பண்ணுங்க. Because the f can remove. Am I correct? எது பிளஸ் வருமா?
plus 2magx.
இது பிளஸ்ஸா?
ஆமா சார் மேடம் இல்ல.
இதா?
ஆமா சார்.
ஓ எல்லாரும் பிளஸ் வரல. ரைட்டா? ஓ இது பிளஸ் வரல. Yes. Super. Am I getting the right answer? எது வருது ஆப்ஷன் வருது? சி வருதோ? இங்க மைனஸ் மிஸ் ஆயிடுச்சா?
B sir. minus 2.
இது மைனஸ் வரும். சாரி. இது மைனஸ் தான வருது? கரெக்ட். அப்ப ஆப்ஷன் பி தான். இது வந்து டிபிக்கல் 5 பார்ட்ஸ் क्वेश्चन. உங்களுக்கு கிளியர் ஆயிச்சா? சோ அப்போ Lagrangian என்ன பண்ணனும் நீங்க? if you want to really prepare for CSIR exam or any exam, குறைஞ்சது ஒரு அப்பர் சிஸ்டத்துக்கு Lagrangian வந்து நீங்க கன்ஸ்ட்ரக்ட் பண்ணி பாருங்க. Question number 3 என்ன சொல்லிருக்காங்க? The one dimensional rigid rod is constrained to move inside the sphere such that its two ends are always in contact with the surface. உள்ளுக்குள்ள ஒரு ஸ்பெரிக்கல் ஷெல்லுக்குள்ள ஒரு ராட் உள்ள போட்டா அது என்னது? உள்ள மூவ் ஆயிட்டா அப்ப என்னது கன்ஸ்ட்ரெயின்ட்? அந்த ரெண்டு எண்ட நான் always has to touch in the inside the surface. The number of constraints on the Cartesian coordinates of the end points. The end point இருக்குல்ல அதோட என்ன கன்ஸ்ட்ரெயின்ட் எக்ஸ்பீரியன்ஸ் பண்ண முடியும். இது வந்து just only to identify number of constraints, that is the problem. இது ஒரு கேட் क्वेश्चन இது. So I have okay. So what are the constraints? First constraint என்னது? It has to move inside the surface. இப்போ அந்த ராட் வந்து இப்படி மூவ் ஆகுது. It cannot move like this. That it cannot go like this. It can go or it can go like this, or it can go like this, or it can go like this, or it cannot go like this, right? Because once it comes out, mean what is the constraint? It has to touch the surface. Both end point has to touch the surface, right? அதுக்கப்புறம் வேற என்ன? So அது ஒரு constraint தானே, right? Then any other constraint? Length constant தானே. We cannot change length, right? அப்போ length constant என்ன constraint அது? x2 minus x1 the whole square, y2 minus y1 the whole square, z2 minus z1 the whole square has to be another z square. Because it can suppose it can here, but even though the x1 y1 z1 changes, this length has to change, right? அப்போ இது ஒரு constraint ஆ? ஒரு constraint. Okay, அப்புறம் என்ன constraint சொன்னோம் நம்ம? எது அதெல்லாம் அப்போ it means wherever it can go, but these two end points has to be on, which means what? The distance has to be always same. That's the meaning, right? If it is end point means what? In the center point இருக்கும் அதோட end point distance வந்து எங்க போனாலும் சேமா தான் ரேடியஸ் தான் இருக்க முடியும், right? Suppose இது வந்து இங்க இருக்குன்னு suppose it is moving like this, then what happens? This will மாறிடும். So to maintain on the surface, the distance from the center point to the end point has to be always same. Here what is the radius? It's the radius, right? What is the radius is here? So it means x1 square, y1 square, z1 square is to be a square. Similarly, x2 square, y2 square. So the more constraint is it can move along the surface. So I have 3 constraints. No more. So answer is now wrong. 3. Of course, now we can free to constrain the Lagrangian. Right? You can feel free to construct the Lagrangian. You will construct it. Of course, but you can pick up. So now what we found? So k is equal to 3. So what is the n? 2. Yes, there are two particles. So 3 into 2, so 6 minus. So it has a 3 generalized coordinates. Okay, generalized coordinates, and of course you can choose the generalized coordinate can be x1, y1, z1. Either one point choose பண்ணினா automatically other point நம்ம. Look at the question number 5. So what is a double pendulum? There are two masses. M, this is L, this is also L, and this is theta 1. This is clear. So now for this double pendulum, we need to. Now first step another. We have to construct Lagrangian. So first step another. Identify constraint. What are constraints there? Suppose I can have x1, y1, z1. So what are the first another? Is around 0? 0. Where? x1 square plus y1 square is equal to L square. Other constraint. Because wherever it can go, this length cannot change. Where constraint? This length also cannot change, right? So now x2 minus x1 the whole square plus y2 minus y1. That's also. This length also cannot change. Wherever it can go, but this length has to be other constraint. What is the constraint equation will be? 4. So k is equal to 4. So now we have the two particles, 3n minus k. So 3 into 2 minus k is equal to 4 over 3. So the number of generalized coordinates for this system will be 2. Right? So this one okay. But the second step another. Choose suitable choice of generalized coordinate. In the case of again, it is moving in the angle direction, right? So it always better to choose theta 1, theta 2 is the generalized coordinate. Okay. So once you choose the generalized coordinate, next step என்ன பண்ணனும்? Express Cartesian coordinates in terms of generalized coordinates. Okay. அப்ப what is Cartesian coordinate first mass? x1. அதேதான். This is the x coordinate x1 and this is the y1. Third projection. So what is x1? L sin theta 1 y1 minus L cos theta 1. What about x2? x2 means what? Okay, அப்ப x1 plus this fellow. சொல்லுங்க.
L sin theta 1 plus
L sin theta 1 plus
L sin theta 2.
Very good. What is y2? Cos theta 1. Very good. So now I express the Cartesian coordinate in terms of generalized coordinate. And very important, this x2 also depends on theta 1 also theta 2. Adha what happen ka? A single Cartesian coordinate depends on more than one generalized coordinate. Suppose in the case of x1 theta 1, but you paranga it depends on both theta 1 and theta 2. Theta 1 and theta 2. Okay. So now next step another the kinetic energy. Kinetic energy formula is T is equal to 1 by 2 m x1 dot square y1 dot square. Similarly another particle, right? Return the particle x2 dot square. So but now find out what is x1 dot. Get one. L cos theta 1 theta 1 dot and y1 dot another L
sin theta
Sin theta 1 theta 1 dot. Very good. Now x2 dot. L cos theta 1 dot. Then L cos theta 2. Are you following? Yes, just plainly do the differentiation. What about y2 dot? Get the y2 dot.
L sin theta
L
sin theta 1 theta 1
theta 1 dot plus theta 2 dot. Okay, this is clear. So now I found generalized velocities of the substitute value. இப்போ நான் நல்லா பாருங்க x1 dot square. So in fact this can be written as 1 by 2m. நான் ரெண்டு சேம் மாஸ் நான் x1 dot square, y1 dot square, x2 dot square, y2 dot square. Now we have both half m half m. They're equal masses. So now look at clearly. x1 dot square. What is x1 dot square? L square cos square theta 1 dot square. What is y1 dot square? L square sin square theta 1. Now if you add both, what I get? L square theta 1 dot square.
2 times.
So first I write t is equal to 1 by 2m L square. Am I correct?
Yes,
So x1 dot square y1 dot square முடிஞ்சிச்சு. Next என்ன பண்ணோம்? x2 dot square. I want to square both. அப்ப என்ன ஆகும்? This is a plus b the whole square again plus a plus b the whole square. If you take a plus b the whole square என்ன ஆகும்? a square plus b square, a square plus of course 2ab 2ab. Can you tell me? So a square into a square அப்ப என்ன ஆகும்?
L square theta 1
L square theta 1 dot square அதே மாதிரி நாம
theta 2
L square theta 2 dot square plus 2L square cos theta 1 theta 2 theta 1 dot theta 2 dot அதே மாதிரி 2L square sin theta 1 sin cos theta 1 cos theta 2 sin theta 2 theta 1 dot. Am I clear? Look like little but it's very straightforward. So for L square I can now write t is equal to 1 by 2m 2L square theta 1 dot square 1L square theta 2 dot square and 2L square theta 1 dot theta 2 dot. Now okay, cos theta 1 cos theta 2 sin theta 1 sin theta 2 cos a cos b plus sin a sin b. Now cos theta 1 minus. So this is the kinetic energy for the double pendulum. இங்க பாருங்க. This is a very best example where kinetic energy not only depends on velocity, also depends on coordinates. Theta 1 in general. Now, what is the potential energy? mgy, right? mg y1 y2. So mg minus mgl cos theta 1 minus mgl. Of course, this will be 2, right? Correct? Am I correct? இந்த ரெண்டு போடுவீங்க. ஒன்று வந்து minus mgl cos theta வரும். நோட் பண்ணா this plus this. So for minus 2 mgl cos theta minus mgl cos theta. Of course, L is equal to d minus d. So which means it's a function of theta 1 dot theta 2 dot theta 1. Am Am I clear? Then what is the Lagrangian equation? Real equation. Two equation. Now, two generalized quantity we have a d by d theta
dou L by dou theta here or one.
And d by d theta
dou L by dou theta.
So you can consider it, but it look like the section right now. So this is a way to construct Lagrangian for double pendulum. So இது வந்து ஒரு டைம். இதுல வந்து இன்னும் கூட நம்ம என்ன பண்ணலாம்? We can increase the complication. அதாவது ஒருவேளை அந்த கிளாஸ் வந்து ரொம்ப பிடிக்காத கிளாஸ் ஆச்சுன்னா நம்ம வாதி என்ன பண்ணுவோம்னா ஒரு வீட்டு பாடம் ஒரு எக்ஸசைஸ் என்னது? Now this m1 m2 are not same. This is m1 and m2. பெண்ணாயிரம் இங்க நீங்க கிளப் பண்ண முடியாது தனித்தனியா வரும் இன்னும் கருப்பாய்ச்சி என்ன பண்ணுவா தெரியுங்களா இது L1 L2 கூட்டுறாரு ஸோ பனிஷ்மெண்ட்டை கூட்டுறது நீங்க ஓவர் செட்டப் பண்ணா என்ன பண்றது அது உங்களுக்கு அசைன்மெண்ட் ஒரு டஃபா இருக்கும் இது M1 M2 மாத்தினாலும் எக்ஸ்ட்ரா ஆகும் L1 L2 மாத்தினா அவங்க அப்படியே பனிஷ்மெண்ட் ஆயிடும் இன்னும் கூட செட்டப் பண்ணா என்ன பண்ணா ஸ்ப்ரிங் போட்டாலும் ஜெனரலைஸ் பண்ண அதிகமாயிடும் இங்க மூணு போறோம் இந்த ரெண்டுக்கு மூணு வந்துறேன்னா இது வந்து கான்ஸ்டன்ட் கிடையாது this will rule out right only this will be there இன்னும் செட்டப் பண்ணா இன்னொரு ஸ்ப்ரிங் சோ இந்த மாதிரி என்னது ஒரே ப்ராப்ளத்துக்கு 4-5 டிஃபரண்ட் லெக்ராஞ்சியன் கன்ஸ்ட்ரக்ட் பண்ண முடியும் சோ ஒவ்வொன்றுக்கும் m1 m2 வேற மாதிரி ஒன்னு எழுதி பாருங்க L1 L2 வேற மாதிரி எழுதி பாருங்க அப்புறம் L1 L2 வந்து is not same right they are spring அப்ப நான் in fact if you put a spring what is the extra issue it will also have a gravitational potential energy also half kx square spring potential energy வந்துரும் ஒண்ணுக்கு போட்டா ஒண்ணு வரும் ரெண்டு போட்டா ரெண்டு வந்துரும் அப்போ கம்ப்ளீட்டா இருக்கும் பைண்ட் ஆகும் லைக் இப்போ நீங்க நோட் இப்படி வச்சு எழுதுங்க ரைட் போர்ட்ரைட் மோட்ல எழுதுனா நீங்க போட முடியும் ஏன்னா லாங் இவ்வளவு லெங்தி ஆகும் ரைட் நாட் லேண்ட்ஸ்கேப் மோட்ல வச்சு எழுதுறீங்க நோட் சோ இத இன்னொரு என்ன பண்ணலாம் நம்ம we can further increase the complication we can say that this pivot point is not fixed it's moving like this further complication so the same problem we can be able to practice நீங்க எவ்வளவு நீங்க பிராக்டீஸ் பண்ற different complication problem அப்பனா உங்களுடைய the understanding will be get deeper and deeper so I'll stop here so I hope today demonstrated certain problems so what lesson you learned today what kind of message that you got today practice பண்ணோம் வேற என்ன நிறைய படிக்கணும் so எல்லாம் புரிஞ்சா அர்த்தம் புரிஞ்சா okay so all the best
நார்மல் கிளாஸை விட இங்க ரொம்ப டெப்தா எவ்வளவு ஈஸியா ப்ராடா சொன்னாரு ஓகே ஐடியாஸ்லாம் நிறைய சொன்னாரு ஸோ அதை கிளாப் பண்ணிடலாம் உட்காந்துருக்கோம் நான் இன்னும் கூட உட்காரல ஸோ ரொம்ப தேங்க்ஸ்
if you want really thank one person you have to thank our எங்களோட குரு ப்ரொஃபசர் எஸ் சத்யநாராயணன் so அவர் தான் வந்து எங்களை உருவாக்குனார் இந்த கிளாஸ் வந்து அவர் இன்ஃபேக்ட் he taught the same class for more than 25 years so அவர் சின்ன இது வந்து அவர் இல்லைனா கூட அவருடைய soul is living in this really kind of very emotional for me thanks
actually it's a long class morning 10 o'clock ல இப்போ வரைக்கும் ஒரு மணி பேசறது நம்ம காந்தி படிக்கிறோம்னா சார் வந்து அப்படி நம்மளோட கான்சென்ட்ரேஷன் செதறாம ஏன்னா கிளாஸ் அவங்களுக்கு இன்ட்ரெஸ்டிங்கா போச்சு அதனால தான் இவ்வளவு நேரம் பார்க்க ரொம்ப தேங்க்யூ